Hi everyone. So I just wanted to go over a couple sample questions from the two sheets that are going to act as your classwork after you finish the notes and your homework if you don't finish in class. So I'm going to pick and choose a couple of examples that I feel are good indicators of the information from today's lesson. And I'm also going to just flip it over to a blank side and show you one more situation for the other sheet, which I don't have printed, that I think will be important for you to know, and it'll be a big hint for how you're supposed to complete some of those questions. So we have different configurations of how lines can intersect and interact with one another and form angles in terms of circles. We have ones that form on the interior of the circle and some that form on the exterior. The ones that were on the interior had 1/2 of the sum of the arcs as its formula. The one outside had 1/2 the difference of the arcs. So those are going to be important to note. So every time they indicate an angle on here, they put a question mark. I'm just going to replace it with x so I can do this work algebraically. So this angle x here is going to be equal to 1/2 the sum of the intercepted arcs. This angle x directly opens up to the 175-degree arc, but it also has an equal vertical angle that is opening to a 55-degree arc. So those are the numbers that I take the sum of for this formula. So we have that the angle is equal to 1/2 the sum of the arcs. So in this case, x is going to equal 1/2 the sum of 175 and 55, which ends up being 230. And so we end up getting 1/2 of 230, or 115 degrees is that angle. And some of these are drawn to scale, but not all. That seems pretty justified for this look that we have for this circle. So that's 1/2 the sum of the arcs for an interior angle formed by our intersecting lines. Whereas this exterior angle, which once again I will mark with an x, would equal 1/2 the difference of the intercepted arcs. So we have a larger size arc that gets intercepted on the outside, marked 140, and a smaller one that gets intercepted more on the inside, marked 50. So x would equal 1/2 of 90 if we subtract those. So this angle apparently is 45 degrees. That also seems justified for this. Okay, so that's if we had the angle in question missing. Sometimes you might be asked for the arc instead. So I'm actually just going to skip down to 7 and 8 to show you those. So here, we still use the 1/2 the sum of the arcs formula, but what we would do is take the angle that is formed by the intersecting lines, that's 85, equals 1/2 the sum of the arcs that are intercepted. One of those is the unknown that I'll mark x. The other is 70. So in order to solve this, I will double both sides. So that's going to end up giving me 170 is equal to x plus 70. So if I subtract 70 from both sides, the mystery arc measurement here should be 100 degrees, which makes sense because 85 is the average of 70 and 100. Okay, let me find one like number 10 here, actually, that has the exterior formed angle from the intersection of our secants. So we have the 50-degree angle is equal to 1/2 the difference of the intercepted arcs. Now, please be very careful when the arcs are algebraic in nature, because when you were doing this, you were taking the entire 12x plus 8, and you were subtracting that from the entire 4x plus 4. So we have to make sure we distribute this subtraction. So this is going to be 50 equals 1/2 this difference, which is 12x minus 4x, 8x, and 8 minus 4, which is 4. Just like over here, though, I will take care of the 1/2 by doubling both sides. So 100 equals 8x plus 4. Subtract the 4 from both sides. 96 is equal to 8x. And we will divide everything by 8. 8 goes into 96 12 times, I think, right? So x equals 12. All right. The directions here were solve for x, so we are done, but please be aware in the future I could have said solve for arc PD, solve for arc SQ, and you would have had to put your x back in, like sometimes the multiple choice questions we've seen try to trick you with. Okay. The last thing, before I let you just get into going with all of this, in our other sheet, which is called, I believe, tangent, tangent, and secant tangent angles, you're going to have a situation where you have a circle that has two tangents intersecting. So we're saying that these are points of tangency. And maybe in the diagram they would extend out, and that's fine. But we have two tangents intersecting a circle, and they might only tell you something like this angle is, I don't know, let's say 40 degrees. Find this arc, and that's all they tell you. Please keep in mind that you do know that the number of degrees in a full circle is 360. So if they end up labeling or asking for only one of the two arcs, you automatically have a label for the other one. If this is x, this is 360 minus x. And I think you're fully capable of using the formula for this because it is the same formula that I used in my last example with you. But I just wanted to make sure no one was stumped and stuck that you couldn't do it because it didn't give you enough information. You can technically have that relationship form. Okay, hope the notes went well for you today. Hope these examples help you get a jump start on those other pieces as well. And I hope you have a great day.